And good evening, Commanders, and welcome to episode 1 of the Elite Dangerous Astro Tour. It's fantastic to be here, and I almost wasn't. So it is good to be here. It is good to be here. I was very concerned earlier on that this wasn't going to happen because some of you may have spotted through Twitter and Facebook and all those other wonderful ways of communicating that my internet was gone. I actually use... because I live a little bit out in the sticks in a place where there is no fibre in the world, then I have to get my internet through a WiMAX transmitter. And unfortunately said WiMAX transmitter was a victim of a bad storm last night when it got electrocuted or filled with water or something. So it was dead. It was definitely dead. And I had no internet for most of the day. But anyway, it is fixed. We are live. We are back, which is awesome news. So thank you very much. So this is going to be good. So it's nice to be back doing the tour, actually. I did really enjoy the law tour that we did earlier in the year. And it seems, dare I say, I don't know if I can claim any or much credit for this, but the law is coming back. Is this not a good thing? So Galnet is back and stuff is happening. People are getting murdered, stuff's getting blown up. The Imperials are rattling their sabers once more. So it's all good. I'm very happy to see that Galnet is back. And the story is being told once more. So that's really, really good. So we will touch on that a little bit just to make sure we keep up with all the news and shenanigans in the Elite Dangerous universe in terms of that. But we have a tour to go on. So without further ado, Commanders, get your ships over to the solar system. I am currently in orbit around the Earth in the Abraham Lincoln Space Station. So if you want to join me in game, it is obviously the Drew Wager private group. And you can join me there. I am in Abraham Lincoln Space Station, so that's where we're going to kick off from. I have a newly prepared ship, specifically for the tour, and named in honour of a famous astronomer who will need little introduction to most of you, but in case you don't know, it will be revealed in just a moment. So there we go. So anyway, lovely to see you all on the stream. So thank you very much. Some familiar names out there as well, and some ones I haven't seen before. But anyway, very, very welcome. If you know my Elite Dangerous streams at all, my streams in general, you know that I do waffle on a bit occasionally. So I'm getting on a bit, and you might have to indulge some of that waffling occasionally. But there we go. So. But we will go on the tour, and it will be full of shenanigans and hopefully the odd fact as well. Because we're doing an Astro Tour. We're not doing a law tour. We've done that. You can find that on YouTube. The Astro Tour is concerned with astronomy, which is kind of my first love, actually, even before computer games. So never let it be said that Drew waffles. No, never. So, and we will do our usual tour and chatting about stuff and hopefully learning the odd thing or two. Getting all our ships out there for some screenies, and there may even be some of those dodgy MIDI compositions along the way for reasons and fun and stuff. So see if I can see if my MIDI compositions are good enough to get me a copyright hit. That's always my objective. Okay, is can I make my MIDI compositions good enough that I actually get a copyright hit? I've only had that happen once so far, which I can't remember even which tune it was. But anyway, we'll get there. Right, so with no further ado, here we are. So we are in Abraham Lincoln Space Station. I'm already in a wing with a couple of folks, Techeron and Lancel. So thank you very much for that. That's for those of you wanting to be in the wing. It's kind of first come, first served. Whoever gets in there first when I come online, I tend to hook up with. So yeah, there's a bit of a competition. I try not to have any favouritism. It's just first come, first served. I just need to switch off my voice comms because otherwise it gets a little bit mad. So there we are. So we are on the Abraham Lincoln. Now we will be tooling around the solar system exclusively tonight. This is an Astro Tour, so we've got to start with stuff that we can see from the Earth. Okay, and in fact, virtually everything that we'll be covering is stuff we can see from Earth, because this is combining astronomy with Elite Dangerous, which is going to be, we'll see how it goes, but there we are. Right, so let me get my spaceship out into the black. Now you may see in the top right corner there, the name of my ship. I built a new Crete Phantom for this, because it's kind of an exploration trip, but we don't need to go that far, at least not in the early stages. I've built a ship called the Carl Sagan. Now, many of you will know or have heard of Carl Sagan. Sadly, he is no longer with us. He would have loved, I think, to have seen a game like Elite Dangerous, where you could fly around in space and explore and visit things. I think it would have been right up his street. Now, Carl Sagan was an American astronomer, very famous, and probably one, I would say, of the best communicators of science and rational thought that the 20th century had to offer. So his Cosmos series, although nowadays it's a little bit out of date given some of the latest discoveries, is still a fantastic thing to watch. So find it. It's actually a Twitch channel, I think, that broadcasts it 24/7. So if you can find that, then go and watch that, or you can find all the episodes on YouTube. It is really well worth a watch. He's got, to my mind, I actually saw him once. I saw him live, as it were, in 1978 when I was a young lad. He gave a series, I think it was either 77 or 78, and he gave a series of lectures in London at the Royal Institution, which were entitled the Christmas Lectures, and as a result of that, it kindled my love of science and space and astronomy. So one of the reasons I am here tonight is because of Carl Sagan. So huge props to him. He's definitely worth looking up. Sadly, passed away a number of years ago now, but a remarkable man. Billions and billions. That was one of his catchphrases. Yeah, so we'll be going billions and millions of miles in honour of Carl Sagan. So that's the naming of my ship. So that's the one I bought tonight. Oh, and don't forget to mention Neil deGrasse Tyson. Oh yeah, he updated Cosmos. Yes, he did. So that's a good point. So yeah, check out all the latest versions of that. It's definitely worth a watch if you're into space and astronomy and stuff. And who isn't, right? Because it's cool. I would love to have met him again as an adult and just said thank you, because I did actually ask him a question when I was 7, but I was so sort of totally and utterly overwhelmed by being in front of TV cameras and stuff at the time that I don't think I came across very well. But it's a fond memory of mine because my dad took me up to see this, and we both got to meet Carl Sagan just briefly, and I can still remember it now. And I was only age 7, so there we go. A famous astronomer and a chap who's actually responsible for putting at least partly responsible for putting the records on the side of the Voyager space probes. And we'll hear a little bit more about him when we get to Mars as well. So anyway, there we go. So here we are in space. And I can see a few commanders already lined up. So let's somebody's already said MIDI compositions. Really, MIDI compositions? Yeah, surely not. Anyway, I've got one. I've got one to start with, actually, because here we are with our starship sitting out in space. So whoever's with me in the instance now, let's just set a gentle course for. That's the Earth, isn't it? Let's set a gentle course for the Earth. Okay, so form up on my wing. I'm going to just roll forward gently, and I can get. Hang on a minute. I thought I had set my dead zone. It's not quite enough. That's so annoying. This is my worthy thrust master. Let me just get this right. My pitch axis dead zone isn't quite enough. Let's just do a tiny bit more. Otherwise my ship will not fly straight. We had this problem before. Right, there we go. Where's the planet gone? I've lost it. Where's the Earth? There it is. So head towards the Earth. That's right. Form up on my wing. Let's get the external shots. There we go. And there we go. And let's turn that off. And there we go. Right. So we might as well kick off. Okay. We might as well kick off with. Have I got the throttle up? Am I rolling? Hang on. Is my ship actually moving? Can't even see. I don't think it is. Hang on a minute. No, come on. There we go. Just a little bit of speed. Not too much. We have a nice leisurely cruise. There we go. That's more like it. Right, join me in a leisurely cruise across the cosmos towards the Earth. There we go. Right, so get that camera. Let's do that. Because there we go. Oh, somebody's actually found them. Good grief! Are they actually online? The Royal Institution Christmas Lectures 1977. The planets. That is it. That is actually it. Wow. Okay, so where is it? Come on, guys. You've left me behind. Where is everybody? Oh, there we go. The ships. This keeps catching me up. But anyway, there we go. I'm going to fly in a straight line. You guys get into shot on the screen. So there we go. Is my crate mode? No, it's a sort of sandy red colour. It was sort of trying to look like the surface of Mars, which of course was Carl Sagan's favourite planet. So that's that's what I was attempting to do there. So anyway, right. So we got a few ships in. Let me zoom out a bit there. There we go. Plenty of ships doing their thing because and midi-composition time. Let me get that over there because obviously starships, right? Starships, which is what we're flying. Starships we're meant to fly. Okay. We've got to start how we mean to go on, right? This is a horrendous tune, but I came across it the other day and thought, actually, that's quite funny. Aim volume's too high, and my mic a bit low. Let me just tweak that up again. There we go. In before Twitch ban, yeah. Now, will my MIDI composition be good enough? It's a really simple tune, actually, MIDI-wise. It's just a repeating pattern, and you just keep changing the key up and down. It's really stupidly simple. But anyway, I thought it was a good way to start. And I like these distant screenshots of us kind of flying through space. It's just, I don't know, something about it just goes me. Right, that's enough of that. That's enough of the silliness for the next 5 minutes. So there we go. Let me get rid of that. To be fair, I didn't spend very long on that one, alright? Just to get that kind of basic tune going. Right, so there we go. Now we need to conduct our tour. So actually, we're here at Earth. Okay, Earth is where we're starting from. The beautiful thing, of course, of Elite Dangerous, he says as he flies around very carefully, just to nudge anybody else's ship, is that all the constellations here are as we would expect them to see from Earth. I'm just looking around for something familiar, actually. So there we go. There's the Orion. Actually, yes, that's right around. There we go. So there's the Orion. There's the sun's right in front of us as well. So you can just about make out the constellation of Orion there. There's Betelgeuse at the top, Rigel at the bottom left. The Pleiades is actually behind the Earth, I think. We can't actually see it from this angle very easily. And we'll have Taurus the Bull and other constellations that we recognise all around here. The clever thing, I mean, Elite Dangerous represents the sky. No silly words for a whole 5 minutes. No, indeed. So let's, the first thing that if you're standing on the Earth and you gaze up into the sky, the first thing you see is the moon. So that's our first destination. Let's head for the moon. And to make sure we can try and keep our wings and our instances together as much as possible, we'll use the space station as a dropout point. So the Galileo space station is our target. So head there. Let's frame shift drive to the moon. Off we go. We can just make it look a long way out from the space station there. Abraham Lincoln. So we can point to the Pleiades. The Pleiades are actually visible. So the nice thing about this tour is actually, at some point, I may be able to take you outside and show you some shots from space, from my garden actually, using some of the cameras I've got of actual things that you can actually see in the night sky. So everything we will see in the Astro Tour will be visible from the ground, and it'll be primarily the northern hemisphere because there we go. Now, of course, it took us 3 days to get to the moon with the Apollo space program. You know, well, not quite interplanetary. Not sure what it is. Inter-satellite flight, perhaps. And the moon is, you know, the second brightest thing we can see in the sky, other than the sun, obviously. You know, it's the natural satellite of the Earth. But it's interesting enough, it's a massive moon. Yeah. We get in the UK as clouds. It's a massive moon compared to the size of the Earth. Okay, every other planet in the solar system that does have moons, because not all of them do, of course. Every other planet that has moons, the moons they're tiny relative to the size of the planet. Now, the Earth is actually quite unusual in that regard. It's got this massive moon. You know, one of the questions is, well, how do we end up with a moon that big? Is the Galilean Space Station. So right, anyway, we'll orientate that and fly towards the moon, which I think is over there. There we go, look at the moon. Looks fantastic. So I'm going to turn it that way up because that's the way that it is inclined from the Earth. So again, I will slow down and folks can kind of form up on my wing as we chat a little bit about the moon. So it is massive compared to the Earth. It is, you know, for a moon of a planet. The moon is enormous, and you kind of ask yourself, well, you know, how did it come to be like that? Where was it? How did we come to have such a massive moon? And you know, when I was a kid, they were still working this out. You know, based on the information coming back from the Apollo missions primarily, because obviously they sampled rocks and stuff from the moon and brought them back home. And as a result of that, they were able to work out better theories of where the moon came from. Because when I was a kid, one of the theories was that the moon had been captured. You know, it'd come in from elsewhere and somehow ended up in orbit around the Earth in this amazingly quite circular orbit. And of course, when they worked out the maths on that, the chances of that actually happening are virtually zero. The moon would have to decelerate somehow into the right place in its orbit and then just sort of sit orbiting around. That didn't make a lot of sense. Another theory was that it was ripped off the Earth by some strange sort of formation, and that didn't seem to work because the moon rocks that came back from the moon, whilst they were similar to the Earth, they weren't the same. So it kind of implied that something had happened to the moon to make it a bit different. And the other theory that was going on at the time was that the Earth had been spinning really fast a long time ago, and a bit of the moon had sort of fallen off from the side of the Earth, leaving the Pacific Ocean basin as the resulting kind of gap on the Earth. That one didn't work either. So none of these theories worked at all. It was a long time after the moon rocks came back from the Apollo missions that they kind of figured out where the moon came from. And they think that there were two Mars-sized planets, one a bit bigger than the other, that actually hit each other, and both of those were sort of precursors to the Earth and the Moon. And as a result of that collision, most of the impacting planet fused with what was the Earth, and so the two cores came together, and the debris that was thrown off by that explosion coalesced and ultimately formed the Moon. So the Earth is like hugely dense for planets in the solar system. Pound for pound, the Earth is the most dense planet in the solar system. And that's weird because the internal core of our planet is really full of iron. It's unusually full of iron. Okay, whereas the Moon doesn't have much at all. It's really lightweight. It's like pumice stone on average. It's only composed of the top parts of the structure of a planet. So the moon's much lighter weight than you would expect it to be, and the Earth is much heavier, which has had massive impacts for us. And one of the reasons we think we're still here, or actually here at all, is because we've got this massive iron core on the Earth. The Earth has a really strong magnetic field which helps prevent the solar wind from eroding the atmosphere and all that kind of good stuff, which has hopefully kept the Earth nice. So the moon is a bit weird, and also the moon, as it orbits the Earth, helps stabilise the tilt of the Earth. If the moon wasn't there, our axial tilt would go all over the shop, over eons, and we'd have radical changes of seasons and temperatures as a result, because the Earth would wobble over on its side, and sometimes the South Pole would point at the sun, and it would be mayhem at times. Whereas the moon kind of stabilises the Earth, so it may be the moon is again another reason why we're here. It keeps the Earth, stable. So having a big moon like this may be, a precursor for the type of life that we are. We don't really know, of course, because we've only got one sample. It's just us. So the moon, contributes to our magnetic field by the fact that it lost most of its core to the Earth, and it also stabilises the spin of the Earth. It's also slowly moving further away, a few centimetres a year, and laser reflectors on the moon are able to, the Apollo astronauts left there are able to, we can measure that using laser beams. So we're firing lasers at the moon all the time, which I think is quite cool. And as a result, we can tell it moving away from the Earth. How cool is that? Now that's my theory for why the dinosaurs were extinct. Okay, because of course, if the moon is moving away from the Earth, it stands to reason that many millions of years ago it was much closer to the Earth. And of course, if you're a dinosaur and you're really tall, you look up, you're just going to get a moon in the face, aren't you? So all these big brontosauruses looking up, oh, what's that? Bang! That's why the dinosaurs were extinct. Okay, not really, but it's quite a cool theory. Anyway, that's the moon. We have to keep moving, because there's plenty of stuff to see just in the solar system, right? So onwards we go. Now let's proceed to the next brightest thing. I suppose we should really do the sun at some point as well. We'll probably do the sun, but there's nothing in orbit around the sun to kind of synchronise. But anyway, head to Venus is our next destination, so let's go there. Have we got anything in orbit around Venus? We have a small station, which is quite good. So Burnell Station. Let's go to Burnell Station. And off we go. Look, there we can see the moon. Interesting enough, the phase of the moon as seen from Earth is the exact opposite of the phase of the Earth as seen from the moon, right? Have I been working on that dinosaur gag? I know it's what I tell my kids over and over again. I did tell that at the Astronomical Society, and I got some very stern looks from some of the assembled people. Some of them get my humour and some of them don't. My game volume is still a little loud. All right, let's just tweak that down a bit. Sorry about that. There we go. Maybe it's a bit tricky. So it's just balancing settings. Far too many things. Has my frameshift drive charged yet? So many ships here, it takes ages. Hang on, I've got somebody going there. Not that button. What's it telling me about there? I don't know. Never mind. Not that one. Right, so come on, frameshift drive. Did it cancel? Oh, must have pressed the wrong button. Still face palming after that game. Mass lock is real. Yeah. I mean, to be fair, when the moon formed, it was probably 4 times closer than it is now. So you can imagine how impressive the moon would have looked in the sky. I mean, it would have been covered in sort of lava and molten rocks, but it would have been like, 16 times as big in the sky, orbiting around really fast. The tides, and the waves generated by the tidal forces back then must have been utterly spectacular. And it would have been quite terrifying seeing this enormous moon looming in the sky. Whereas, of course, now the moon is that much further away. So there we go. Yes, so I suppose I should have done. I should have done a Europe song here, shouldn't I? We're heading for, which, to be honest, is the worst, I think, personally, is the worst line in the history of singer-songwriting ever. we're heading for Venus because maybe they've seen us. It's a shockingly bad line, that. So where were we going? So we are we're currently flying around the solar system. So the Asteroid Tour starts with things that are very local to us, and then we'll move out into space over time. Probing Uranus. Well, that's another one. Of course, we will come to Uranus, Commander Kelvinator, in due course. Anyway, right. Let's get to Venus, because maybe they have seen us. That is a shocking line. It's quite funny because my kids are obviously now, after many years of indoctrination, are custodians of 80s music, so they know most of those lines. And we just roll our eyes and sing it really loud. So yes, it's the Final Countdown by Europe, which is a sort of soft rock band from the 80s. For those of you who are too young to know these things, it's not a bad song, but it's just that's just an appalling line that's in that particular song. So we have sent quite a lot of space probes in real life to Venus. Okay, so Venus is in many ways, and Carl Sagan himself. So going back to Carl Sagan for a moment, Carl Sagan was instrumental in understanding what was going on Venus, because prior to the space age, we looked at Venus. Well, it's an Earth-sized planet. Okay, it's closer to the sun, so it's probably going to be a bit hotter than the Earth. It's clearly covered in clouds. We can see that in the telescope. So lots of clouds, close to the sun, nice and warm, same size as the Earth. Bet you it is covered in rainforests. Okay, it's a sort of Amazonian planet, and probably quite a nice place to go if you like rain and trees. So all these, again, lovely romantic images of what the surface of Venus would be like, and that's what everyone assumed up until the 1950s, that Venus was going to be like. But Carl Sagan actually shot this one down, and he was very much into radio astronomy, and he was one of the early scientists working with people to point radio telescopes at things. And when they pointed a radio telescope at Venus, they've discovered it was giving off massive quantities of radio waves, and those radio waves were indicative of extremely high temperatures, and really off the scale high temperatures. And there was no other explanation other than the surface of Venus was ridiculously hot, and it was found to be 200 plus degrees centigrade on the surface, hot enough to melt lead on the surface. And when we did eventually get space probes to Venus, and the Russians managed to land too. Can you believe they actually managed to land on the surface of Venus? Those space probes lasted for about 30 seconds before they were obliterated by the surface conditions of this planet. And it's interesting enough, even in Elite Dangerous today, whilst Mars, as we'll see in a bit, has been terraformed in the time of Elite Dangerous, it appears that nothing has been done to Venus in the time of Elite Dangerous at all. And that's really because, and as we know, David Braben is a big fan of, there's Venus there. David Braben is a huge fan of kind of astronomical accuracy. And Venus is basically a really nasty place. The atmosphere of Venus is mostly carbon dioxide. The theory being that it had some sort of runaway greenhouse effect, and the planet's atmosphere, it probably started out quite like the Earth's, but with the increased solar radiation being close to the sun, and also the heat. Basically, the oceans evaporated. Any water that was the protomolecule, yeah, that's the expanse. Slightly different science fiction franchise, but the surface of Venus was heated up. The water slowly boiled away. The water, as water vapor, was hit by ultraviolet radiation from the sun. That disassociates it, leaves the oxygen around. The hydrogen escapes into space. The oxygen effectively kind of rusts the surface, oxidizes everything, leaving really just the carbon dioxide, left. And what you're left is today Venus, and still it actually appears in the time of Elite Dangerous. Nothing's been done to Venus because it's such a ghastly, horrible place. The pressure at the surface of Venus is something like 90 atmospheres. So it's about the same pressure at the surface of Venus from the atmosphere that the wreck of the Titanic is. So that's the sort of pressure you're dealing with down there. On top of the pressure, there's the temperature, which is way above 200 degrees Celsius. So it's just incredibly, incredibly hot down there, hotter than your oven by quite a long way. So that's crazy. And if that wasn't bad enough, it also rains apparently, though probably not on the surface. Probably from certain clouds on the way down. It rains sulfuric acid. So that's why Venus is not a great place to go to. So it's too hot, there's too much pressure, and it rains sulfuric acid. So it's not a nice place to visit. That just sort of shows how different two arguably very similar planets can be. So Venus and Earth are not dissimilar in the basic building blocks that they have. Venus is it's like 98% of the size of the Earth. So it's virtually the same mass, density, everything else is comparable. And yet, this planet is an absolute hellhole, and Earth isn't, at least not at the moment. And it shows the power of the greenhouse effect. So I don't want to get into a political pitch on global warming or anything like that, or climate change. But Venus is where climate change went completely and utterly mad, and basically obliterated the surface of the planet and made it impossible to get down onto. We've got total eclipse of the asp. That's quite nice. So Venus is not a nice place now, but oddly enough, Venus does have a couple of redeeming features. One is that it is the only place in the solar system where potentially you could stand outside an asp eclipse. Yeah, an asp in front of things, an asp clip. I like that coordinator. That's really good. Venus is the only planet where you might be able to, on a floating platform in the atmosphere, quite high up above the ground. If you could do that, it might be the only place in the solar system, other than the Earth, where you could stand outside with enough pressure around you that you wouldn't need a spacesuit. High up in the atmosphere of Venus, there is a place where the pressure is about the same as on the surface of the Earth, and the temperature is not dissimilar either. You might still have problems with sulfuric acid, but if you could put a floating platform or a balloon or something in the atmosphere of Venus at a certain height, you could walk outside with just a face mask on, to provide you with oxygen, and actually be okay, theoretically. I think I'd like some other people to try this first. But that's the only place in the solar system other than the Earth where that's actually a possibility, because it's warm enough and there's enough pressure. The recent scientific discovery, of course, of Venus is that there's phosphine in the atmosphere. Now, phosphine is a nasty gas that stinks of fish, but it may be, and I stress maybe, it may be the output of microbes living high up in the Venusian atmosphere. We're going to have to go back and do some more science and find out. So there's Venus. So Venus is interesting. So there we go. While your unmasked part dissolve. So I don't know how strong the sulfuric acid. How strong the sulfuric acid on Venus actually is, whether it'll be face melting type of acid, or whether it's kind of just the sort of stuff that's going to irritate a bit. Somebody else can try that first, right? There are no comparative regions in other gas giants. No, because they're too cold. The temperature of the gas giants is way too cold. You could probably find pressure, yes, but not temperature. Venus is the only place where you get temperature and pressure at the same time, that we know of anyway. And I think that's unlikely to be change, because everywhere beyond the orbit of Mars is so cold it's just unimaginably freezing. So there we go. Anyway, so that's Venus. Onwards we must go. So set your course for Mercury next, and we'll go. We won't need to do too much of Mercury because it's relatively boring, but it's got to be done for completeness. We've got to do our tour. So off we go. System map. Right, so we have a big orbiter, the Daedalus orbiter at actually, what type of planet is it in Elite Dangerous? It is a high metal content world. So that's basically what it's described as. There we go. Look, surface pressure 93 atmospheres. Okay, surface temperature 735 Kelvin. Not very nice. And there we go. Locations: human 1. Well, interesting that. I wonder if there's actually something down there that maybe one day we can visit. There is a surface port on Mercury actually, but in fact we could go down there. Let's do that while we're here, because it's one of the only planets. In fact, it is, I think, the only planet in the solar system that actually today, and we don't know what Odyssey will bring, but certainly today it's the only planet in the solar system that actually has a base that we can visit. So it's the only planet, and in fact there's several, so let's choose one that's on the daylight side. So Erlich City, we'll head to Erlich City. Okay, the city on Mercury is kind of cool, well, hot. So there we go. Let's head for Erlich City. That's where we're going to go, and see what we can see. So we'll leave Venus behind ourselves and head over there. Mercury, of course, is the first planet out from the Sun. It's the closest planet to the Sun, way closer than the Earth. It's about 30 million miles, I think, away from the Sun, whereas we're about 95 million miles away from the Sun. And it has a strange sort of rotational orbit. It's kind of in what they call an orbital harmony, and it rotates, I think, twice for every time once it goes around the Sun. And it was it's got that kind of weirdness. So it's not tidally locked as you might expect it to be at such a close range, but it is it's got this kind of weird orbital resonance that's going on, which keeps it close. So the Sun does rise and set on Mercury, but not in the same way that we would kind of anticipate it on the Earth. We days and years. In fact, actually, Venus is really weird in that regard. Its day is longer than its year, so that must be very spooky. Not that you can see anything from the surface of Venus anyway, but Venus takes so long to rotate on its axis that its day is actually longer than its year, which must make a Venusian calendar quite a difficult thing to figure out. But you wouldn't be able to see anything from the surface of Venus anyway, so the chances of actually having a calendar are fairly low. I don't think the microbes are all that bothered about that sort of stuff. We tend to take things like days and months and years, of course, for granted because we're so used to using them, but of course they are just a reflection of the way our planet orbits the Sun and it spins on its axis. It's just a way of organising ourselves, but many planets have years and days where that just doesn't work. Okay, it doesn't make any sense to do it that way. It's an arbitrary convention that we're used to because we live on the Earth. So there we go. Hello, Omniwolf. So anyway, apologies. I probably haven't been able to say hello to many people in the chat because I'm sort of chomping through my planetary descriptions. But anyway, it's lovely to see you all on the chat. So yeah, feel free to keep saying hello, and a general hello to everybody out there. So thank you very much for coming along. It's always good fun to see you all and sort of fly around in game doing weird stuff. So anyway, good to have you aboard. Right, so we're heading to Mercury, okay, in the solar system. So this is not far from home. Now you can see both Venus and Mercury from the Earth. Venus is actually up at the moment. It's dead easy to spot. It's the brightest thing in the sky other than the sun and the moon. So you can't really mistake Venus, okay? If you see a really bright, and it's just a pinpoint of light in the sky to our eyesight, but if you can see a really bright star in the sky shortly after sunset or shortly before dawn, the chances are almost certainly it's Venus. Okay, it's noticeably brighter than any other stars in the sky. It's really quite dramatic. Okay, so you can't miss Venus. Mercury, however, is much harder to see. It's not particularly bright. And because it's in what we call an inferior orbit, i.e. it's inside the Earth's orbit, it doesn't get very, very far away from the sun in the sky at any time at all. So you can only see it when it's at its greatest elongation. And as a result of that, it's quite hard to spot. So you have to be a little bit careful looking for it, because you tend to be looking for it very, very close to sunrise or very, very close to sunset, and you've got to be a bit careful as a result. You mustn't scan for it using binoculars or anything stupid like that, because if the sun is still in the sky when you're looking, you've still got the danger of zapping your eyesight by looking through binoculars or anything like that. So be careful. Okay, that's a standing rule for any astronomy. Okay, if you are using a telescope or binoculars or anything like that, never ever ever look at anything in the sky with binoculars or a telescope whilst the sun is up. Okay, that's a golden rule of astronomy. Never ever do that, right? Because the sun is incredibly bright, as we know, but if you focus that light gathering power of a telescope or a pair of binoculars into your eyeballs, it will make you go blind permanently, very, very likely. And there aren't actually any pain receptors in your eyeballs. I don't know, on the retina, shall I say. There aren't any pain receptors in that part of your eye. So you can look actually, and early astronomers did this, crazily, because they didn't know any better. But early astronomers actually did look at the sun through their telescopes, and some of them, the telescopes were so shockingly bad at the time that you didn't gather enough light power to be immediately harmful. But many of them did go blind as a result, and they didn't know they were going blind, rather tragically, because there aren't any pain receptors in your retina. You can sense the heat coming through, but the actual damage doesn't cause any direct pain. With even the smallest commercial telescopes that you can buy, off the shelf things nowadays, you would instantly go blind if you looked at the sun through them. So please, please, please do not do that. All right. If the sun is up, don't use your binoculars or telescope and look anywhere close by. All right, it's extremely dangerous. So Erlich City just literally disappeared in front of me. That was a bit glitchy. Right, so we're on the surface of Venus. So not Venus, Mercury. Now Mercury actually is. Let's slow down a little bit there. There we go. We'll just fly around here for a little bit. I'm just going to kind of hover in space. I should be able to throttle back, shouldn't I? Yeah, I know, but I'm not going to dock. I'm just going to hang around in space. And we can have some nice screenies of the base. The bases here, that's a rather pretty base, isn't it? I think they're quite nice looking. And there's the surface of Mercury. There we go. So anyway, you can see Mercury from the Earth. It's quite hard to see. You have to look up. The easiest way to do it is to just get some astronomy filters, astronomy software, work out exactly where it is. Okay. Ooh, that's slightly sea-sickening, isn't it? I don't know why it does that. That's a weird effect when you're sort of hovering in space, because surely you should be staying still. There's no atmosphere here that should be blowing me around like that. So I'm not quite sure why Elite Dangerous makes you float around in a slightly seasicky sort of way there. You can look at the sun through a solar filter. I personally don't even recommend that, because your solar filter could have a scratch in it, or it could have a crack in it that you haven't spotted. I always prefer and recommend the projection method of looking at the sun. So if you do want to see the surface of the sun for a telescope, you point your telescope at the sun without actually looking through it, and project the image onto a thing. Yeah, I think that's going to make us ill, isn't it? Let's get on the ground. We don't actually have to dock with the station. Let's just land on the ground. There's lots of shadows. Let's head down there. I'll just park on the surface briefly while we talk about Mercury. Let's get Mercury, because we've got lots of other planets to visit. In fact, to be honest, there's not much to see. Mercury is a desolate, barren planet. Okay, so let's not hang around here too long. Because it's not particularly interesting. The only thing interesting about Mercury actually is it is, oddly enough, it's not the hottest planet in the solar system. It is you'd thought being closest to the sun that it would be, but it isn't. And the reason it isn't is because it doesn't have an atmosphere. Mercury is both one of the hottest and the coldest places in the solar system. So the side that's facing the sun is, not surprisingly, really, really hot, but it isn't as hot as Venus because it doesn't have an atmosphere. It's not retaining as much heat. And its dark side, when it's facing away from the sun, there's no radiation there at all. So it's incredibly, incredibly cold. So Mercury has a massive heat differential between the hot and the cold side, which planets like Earth and Venus, which do have an atmosphere, don't have. So yeah, really, really wacky. It's the only planet that is liquid at room temperature. Mercury. I see what you did there. So Mercury, it's mostly a barren rock. It looks very like the Moon. It's much, much denser than the Moon. It has a big iron core. Its iron core is so big that it appears that maybe Mercury was hit by something early in its life which stripped off some of its outer layers. And as a result, it is, it's got a very dense, big core for the size of thing it is. A completely different internal structure from the Moon, but externally it looks rather similar. So there we go. Mercury sounds like an ex-girlfriend of mine. A really dense core. And she stripped off her outer layers. I think we could probably push that analogy too far. Anyway, so let's get to Mars. Now, Mars in Elite Dangerous is not how we see it today, as we know, but we'll talk a bit about that. So let's head for Mars High, which sounds like an American high school to me. Sounds like a sort of should be like a musical. Mars High, the musical, and of course we're on the wrong side of the planet, so we're going to have to frame shift out and around a little bit first. So let's head for Mars High next. So I heard the suggestion one time recently that Mercury is the ancient core of a gas giant. It could be, yes. There's lots of theories about how the planets in the solar system arrived where they are, and what caused them to be. We know the Earth, at least we think the Earth was caused by a massive collision between two Mars-sized objects. Mars seems to have existed on its own. Venus is very similar to the Earth, but no moon. Mercury appears to have lost its outer layers at some point, and that just shows in the formation of the solar system lots of weird, collisions and debris was flying around, and it was a very, very chaotic place. There's a Mars High School in Mars, Pennsylvania. Excellent. Right, so we're going to frame shift around Mercury. I need to go up there. Look, I haven't got an escape vector. Off we go. And head for Mars High. So let's see how that goes. Smarty for you says, great, now I've got singing Matt Damon in my head. Mars High. What was that? High School Musical? That was the one I was thinking of. High School Musical on Mars. I think my kids watched that a long, long time ago. Mars has a megaship in orbit, says Techeron in the chat online. A Sagan class traveller. Well, there we go. There's a nod to Carl Sagan in Elite Dangerous. I'm sure there are some others actually, but it would be good to know how many Carl Sagan nods there are actually, because I'm sure he's well represented in Elite Dangerous. So there's Mercury. Now let me just switch to that view. We can see Mercury going past the corners, and lots of people in frame shift drives. But Mercury is pretty dull. It's just a barren rock in space. Although there might be all sorts of mineral wealth there. Who knows? That future space travellers like ourselves in Elite Dangerous might be able to exploit. Who knows? There definitely is a little bit of thinking that Mercury might be economically useful in the future, because of course you've got that amazing temperature differential which gives you heat and energy, and probably a lot of metal down there, so it could be a really useful place to build spacecraft and stuff, because you've got low gravity, lots and lots of energy, and lots of raw materials. So it might be, hundreds of years from now, quite an important locale for spacecraft manufacture, that sort of thing. Who knows? We'll have to wait and see. I probably won't see it, but we'll have to wait. Maybe humanity will have to wait and see if we ever get off this rock. That's a beautiful thing about Elite Dangerous. It gives us a view of the future. Now, it's not a very realistic view of the future, but it's a view. Okay. And it gives us hope that maybe we will get out there one day, and we'll see how it goes. Anyway, thank you very much for the folks who are following as well. I do appreciate that too. Really, really good. So let's head for Mars. Now we're going out beyond the orbit of Earth. Now Mars, I gave a talk about Mars, which you can find on YouTube if you're interested, a little while ago. So Mars is a planet which is, of course, very much steeped in science fiction lore. 100 years ago, probably a bit more than that now. 100 years ago, perhaps a bit more. We just assumed there was life on Mars because it was like, well, it's obvious there's life on Mars, right? Because it's kind of like the Earth. Through our telescopes we can see there appears to be vegetation on the planet moving around season to season. It's got ice caps, and one of our top astronomers, Percival Lowell, can see canals on Mars with his huge telescope in Arizona, and everyone just assumed there was life on Mars. And it wasn't until the space age, again, when we sent some space probes out there, started taking pictures of Mars and found out it was covered in craters and barren and the atmosphere is really thin, that again, our notions of lovely habitable worlds, full of, alien princesses needing rescuing and all that sort of stuff, was completely destroyed. We had this, probably not unsurprisingly, okay, a very romantic view of what these planets were like, and unfortunately, those views have been destroyed by science. There are no Martian princesses, and there are no Amazon warrior ladies on Venus. They've all gone. Science has basically destroyed them by showing us that Venus is a ghastly, horrible place, and Mars is, at least today, Mars today is a dead or dying world. It's lost its atmosphere to space. It's arid, it's dry, it has a very, very thin atmosphere. An atmosphere so thin it hardly counts as an atmosphere. In fact, in many locations, the atmosphere of Mars would be considered a pretty good vacuum. Mars is tantalizing. It does have ice caps. It appears that it did have water a long, long time ago, and here we are at Mars High Space Station. Blue tunneling, there we go. Ooh, almost came out into the space station. Right, so I'm going to set a gentle course towards Mars. There we go. Mars is, Mars today is barren, arid world that used to have water on it. We can see the signs of water all over its surface, where it used to be. There's riverbeds and dried up lakes and all sorts of interesting stuff, but it's all gone. Mars seems to have been too small. Tenuous atmospheres is the word, that's right, so maybe we'll set foot on there one day. The chances of anything coming from Mars are minimal. Well, hold that thought, Commander Coordinator, hold that thought. Yes, Carl Sagan was in the presentation as well, yep. So there is a thing about Percival Lowell and canals and channels. It was a mistranslation of the Italian word, but he certainly saw a bunch of things on Mars that aren't actually there. He produced some very lovely maps, and unfortunately those maps are mostly wrong because the things that he thought he saw he didn't see, and he assumed that the Martians were funneling water down from the ice caps, which is a lovely notion. But alas, there is nothing there of that type. And Mars, we think, suffered really from being too small. Mars is about a little bit more than half the diameter of the Earth, and it did have volcanoes in the past, and it may have had plate tectonics in the past, but geologically now Mars has sort of solidified because it's that much smaller. It's lost its heat to space much faster than the Earth has. Its magnetic field has therefore reduced dramatically to the point where it's hardly got one at all now, and as a result the solar wind from the sun has eroded the atmosphere of Mars, and as the pressure on Mars dropped on the atmosphere, any water on the surface would begin to boil away. And if you've ever seen the experiment where you put water in a vacuum And if you drop the pressure down, the water will start to boil at room temperature. And in space, in fact, if you put water in space, you can make it boil and freeze simultaneously, which is quite a weird thing to watch. You know, you can't. For the same reason, you can't make a good cup of tea on the top of Everest, because you can't get the water to boil at a decent temperature. It's the same reason Mars' water has gone. It's evaporated into space and been lost, blown away from the planet by the solar wind. And you're left with this planet that used to have water on it, but it's now just an arid dust ball. Now, in the time of Elite Dangerous, we've managed to sort of reverse that process and bring water back to Mars. We terraform it in the 22nd and 23rd century. And it, you know, it looks like that now. Let me go back outside. Sorry, should have been doing that. Oops, wrong button. Mars has been terraformed in Elite Dangerous. Now, that is a tantalizing possibility for us, but it would be fraught with difficulty. Well, the first thing is, where do you get the water from? Because you're not talking a small amount of water there. Okay, that's a lot of water on that planet, which has got to come from somewhere. Is it comets? Do you get a whole bunch of comets and drop them onto the surface? Well, that could be quite fun, I suppose. But where do you get the comets from? And enough comets, you'd have to get them from the Oort cloud, which is quite a long way out, the Oort cloud. And things like that are a tantalizing possibilities to terraform Mars, but it would not be an easy or quick job. But we've apparently managed to do it by the time of Elite Dangerous, which is cool. But Mars is fantastic from that point of view. It's got a rift valley, which is way bigger than anything on the Earth. It's got the biggest volcano, extinct, but still the biggest volcano in the solar system, Olympus Mons, which you can still again see in Elite Dangerous if you go and visit the surface. So it's quite an interesting place. It's quite an interesting place. In our reality, Mars has two moons, Phobos and Deimos, and oddly enough, in Elite Dangerous, they've both disappeared, which is most peculiar. And they were there in the previous games, as we discovered on the Lore Tour. So between the year 3250 and 3300, the moons of Mars mysteriously vanished. And I asked FDev for an explanation of this, and they haven't answered. So. So who knows? There we go. Who knows what happened to those? And in fact, Ceres, which is one of the big asteroid belts, that's objects is not there either. So we don't know what happened there. So that's most peculiar. I will ask them again. We're here back in Mars. What happened to Phobos and Deimos? Because we just don't know. Some people think they were used for generation ships, but this is too late in the day. We're not building generation ships anymore. Was Mars terraformed in previous versions of the game? Yes, it was. So in Frontier Elite 2 and Frontier First Encounters, Mars was indeed terraformed. Oddly enough, in 3250, in the third game, Frontier First Encounters, Earth was actually completely covered in smog, rather like Venus is, that was actually because the rendering engine couldn't cope with making a representative Earth. So David Braben covered it in smog so he didn't have to render the surface, apparently. And fun fact, Mars is actually the federal capital. So yeah, actually Mars is the classy up and coming suburb of Earth, really. So Mars is the trendy, expensive part of the solar system to live in, whereas Earth is a bit more kind of, well, that's a little bit touristy by the time of Elite Dangerous. So Mars is where all the posh people live, right? And we can't go to Ceres because it's not in the game. There should be an asteroid. There should be an asteroid belt. So anyway, onwards into the solar system we go. That's Mars. Where are we? So system map. So yeah, so in the system map, here's the asteroid belt, which we can't go to. There's no cluster present. So the most famous asteroid belt of them all, our asteroid belt, we can't actually go to in Elite Dangerous because there's nothing there. So there should be Ceres and Pallas and a bunch of other decently sized asteroids here, but they're not there, which is a bit weird. So anyway, we now need to move out into the solar system, so to go to the gas giants. So we've only dealt with the terrestrial stuff. Carl Sagan once called the terrestrial planets just the rubble left over when the main event had happened. So we are we're looking at the big stuff now. So let's fly to the Columbus Space Station. This is in orbit around Io, which is of course in orbit around Jupiter, which is the biggest planet in the solar system. Now, Jupiter here on the system map is represented with these really bright rings. That's not realistic. Okay, can't they don't really look like that. They are there, but they're not very bright and they're not very thick, not compared to the rings around Saturn. So that's a little bit disingenuous to have them look like that in that thing. We'll see what they look like when you get closer. So anyway, off to Columbus we go in orbit around Io and Jupiter. Boom, off we go. Dun, dun, dun. It's a little bit further out now. The old games, actually, Frontier Elite 2 and Frontier First Encounters, used to measure distances in astronomical units and then millions of miles, which I actually found a bit more intuitive, because I know how far an astronomical unit is. It's quite a good measurement. An astronomical unit is the distance from the Earth to the Sun, which astronomers helpfully say that's a 1. Okay, so Mars is about 1.8 astronomical units away from the Sun. It's quite a bit further out. Jupiter is 5 astronomical units out. Its orbit is 5 times as far as the Earth, which means it takes 12 years to go around the Sun compared to our 1. So its years are pretty long. Its day is much faster now. Actually, Jupiter spins quite a lot quicker than the Earth does, which we'll see when we get there. But in Elite Dangerous we use light seconds for some reason. So 1 AU equals 500 light seconds. So that's sort of the way to work it out. But light seconds are, I don't know, I don't find light seconds very intuitive. I suppose I've grown up with astronomical units. I know how far away things are. It's a bit like miles and kilometres. I understand the kilometre, but I have no idea instinctively how long a kilometre is. Whereas if I say that's a couple of miles away, I know what you mean. Which is probably just me being old and imperial. Huzzah! And yeah, Ceres as an asteroid is big enough to be round, so it's a big chunky asteroid. So it really should be in Elite Dangerous. We should definitely petition for Phobos, Deimos, and Ceres to be added to the game. I thought we were talking metrically. Yeah, so I suppose that's a nod to the modern things, as we tend to use metric things in Elite Dangerous. But I must admit, I prefer astronomical units and to light seconds personally. It's just a thing. I wish there was a little toggle. Yeah, I mean, most sat navs have a toggle between Celsius and Fahrenheit and kilometres of Mars. Why can't I have a toggle in my cockpit between astronomical units and light seconds? Get with it, Drew. Use light seconds. Only a small-minded Earthlings still use. Yes, you're probably right. You're probably right. So there we go. And we use these which is megameters, isn't it? Which is I think 1,000 kilometres. And then we go into light years and parsecs. Well, the universe is big, isn't it? It's way too big. I was discussing that on my stream on Monday. Is that light speed isn't fast enough, obviously, and in Elite Dangerous, obviously we have a frame shift drive and we have hyperspace technology, which allows us to get around a lot. And you can see here I'm actually travelling now at 23 times the speed of light, which is a jolly handy thing to be able to do when you're doing a tour of the solar system. Otherwise, it'd be extremely boring. It just shows you even the solar system is a big place. Okay, it's a big place, and it takes our space probes, even the fastest ones we sent out, into the darkness, years and years and years, even to get to Jupiter. It's a long way. And we don't have the technology to go at any decent rate. Now, the first decent exploration of Jupiter was done in the 60s and the 70s. We sent some space probes out there, Pioneer space probes, and then the Voyager space probes. And I remember very clearly again, going back to Carl Sagan's lecture in 1977, we were awaiting with bated breath better pictures, because we didn't have good pictures of the planets in the 60s and the 70s. All the images that you see, most of the images, certainly up in the 80s and the 90s, were all the Voyager ones, because there was nothing else. And since then, we've sent quite a few space probes in this general direction, and we have much better pictures. But before the 60s, there was nothing at all. The best pictures we had were through telescopes, and we had no idea what the planet really looked like, or what the moons looked like at all. In the time of Elite Dangerous, we can just take a tour. We can just tour around the planets in an afternoon, which is totally nice. you know. And interesting enough, these 4 satellites, they're called the Galilean Satellites: Io, Europa, Ganymede, and Callisto. And we are. They're called that because Galileo first saw them. So Galileo, just a little bit over 400 years ago, first, you know, some people credit him with the invention of the telescope. He didn't invent the telescope. He may have been the first one to look at it. He was certainly the first one to look up at things and write them down and publish them. So he certainly gets the credit for that. He definitely didn't invent the telescope, Galileo. But he was almost certainly one of the first people to record what he saw, and he looked up into the sky using one. And he looked at the moon and saw that the moon was covered in craters and, you know, mountains and riddles and all sorts of interesting things. And then he pointed at Jupiter and was surprised to see 4 dots that changed position from night to night. And those 4 dots that he saw are the Galilean satellites, one of which we're now in orbit around, which is Io, which I don't know where Io is. Where is it? I'm just going to fly around here for a moment before. There's the space station. Where's Io itself? Let's fly towards Io for a bit, if I can find it. There it is. So again, let's just cruise a bit. So the Galilean satellites. Jupiter actually has loads and loads of satellites. There's only 4 represented in Elite Dangerous, but Jupiter has probably something in the order of 60 actual satellites. And that's because most of them are quite small. All right, most of them are quite small. Commander Jello Wiggler, hello, sir. Thank you very much for popping along. I do appreciate your visit. Thank you very much for popping along. Commander Jello Wiggler, of course, is the father of the dear little girl who died earlier this year, Evelyn, who I was very privileged to write a story for, and we will be visiting her memorial in game at the end of this astronomical tour. So it has, for those of you who haven't read that story, it's online. I'm sure you can find it. And we will be visiting Evelyn's Light. It's quite a long way out, so it's only for those of you who are in for the long haul. But we will be visiting Evelyn's Light, which is a star way out in the depths of the galaxy, as part of the tour, right towards the end, because it has a Christmas theme, which we will get to in due course. So anyway, lovely to see you, Commander Jello Wiggler. That's fantastic for you to pop in. I do appreciate the visit. That's great. Lovely to see you. Galilean moons, 4 of them. Jupiter has about 60. They're not represented in Elite Dangerous. Most of them are just captured asteroids, really, really small things, but a few of them are interesting. But this is Io, which is the closest one to Jupiter itself, and it's a very weird moon. Actually, before the Voyager space probe got to Evelyn's Light is like popping out to pick up milk if you happen to be in Colonia. Yeah, it's quite close to Colonia. It's a long way to go from where we are at the moment, which is the Sol system, so it's about 20,000 light years away. But we will do it. We are planning a trip out there, so we've got a lot of things to seal this tour, but right near the end we will be, for those of you who are interested, we will be taking a trip out to Evelyn's Light. That would be a fantastic thing to do. I haven't seen it yet in game, so I do want to go out there and have a look. It'd be nice to do it in the company of all my fellow Astro Tour companions, so that'd be really good. So Voyager 1 and 2 gave us the first pictures of these satellites, and we were expecting just cratered, rocky, boring moons, a bit like the moon itself, maybe a bit like Mercury. We were rather surprised to discover that they weren't like that at all. Io was an absolute hellhole of a moon. It's probably the most volcanically active place in the entire solar system, and you've got to ask yourself, hang on a minute, it's really small. It's a small moon, and it's covered in volcanoes. How can it be covered in volcanoes? And it's so active that basically geography doesn't really exist on Io for more than a few weeks and months, because the surface is constantly being changed by the activity of all the volcanoes. It must be one of the most tectonically unstable places in the solar system. There's lava spewing out all over the place. And the reason being is as Commander Terra Firma says, it's got a slightly elliptical orbit around Jupiter, which means it's being squashed and squeezed by Jupiter's gravity as it goes round. And that is enough to keep the inside of Io completely molten. And it means it's just erupting with lava all the time. So, the gravitational force of Jupiter is what is keeping Io molten and keeping it thing. So where we expected to see a completely dead moon, what we've actually discovered is a massively geological active place that's spewing sulfur and lava into space all the time. So yeah, it's a really, really, really place. Io is very, very unusual. Some of the other moons are equally wacky as well. So Europa is a good candidate. I'm just going to see if I can fly towards Jupiter for a little bit so we get that on the screen. I wish the scanner would show us where the planets actually are. There it is. So let's fly towards Jupiter. There we go. That looks nice, doesn't it? So Europa, the second moon out, is covered in ice. Okay, covered in ice, and its surface is, it's totally smooth. The ice is very, very smooth. There's no craters visible on the surface of Europa, which implies the surface of Europa is extremely young, and that, again, there are processes in operation that are smoothing the surface of Europa in geological timescale. So something weird and wonderful is happening down there. They think the same tidal forces are working on the core of Europa as well, which may mean that the interior of Europa is liquid as well. And that may mean that beneath the external ice that we see on the surface, there could be an ocean of liquid water underneath the ice. Now that gives tantalizing possibilities for life there as well, because we've discovered on Earth there's these things called fumaroles, which can grow on the surface of the ocean floor on the Earth under incredible temperatures and pressures without any sunlight. And if they can do that on the Earth, maybe they could do under similar conditions if the conditions are similar inside Europa. We need to send a probe down there, which is an undertaking of pretty dramatic. You've got to get a probe across space, land it on the surface, drill a hole through the ice, then swim down through an ocean and look at the ground. But if you could make a probe do that, maybe there's some interesting stuff hidden in the oceans of Europa. So who knows? That's going to be an interesting thing to see. Ganymede and Callisto are less interesting. They're much more traditional kind of rocks in space, really, full of craters and stuff. Oddly enough, Callisto seems to have an awful lot more craters than it should have. It seems to be a really heavily bombarded moon for some strange reason, which is not entirely clear. Jupiter itself, of course, is the biggest planet in the solar system, so it is bigger than everything else combined, other than the Sun. Yes, it is the setting for 2001, which Elite owes quite a lot of its inspiration for. I think the rotating space stations are definitely a nod to 2001, and the Blue Danube theme tune that you get when you dock with Elite Dangerous, that comes directly from 2001: The Space Odyssey, the film version by Stanley Kubrick. And you'll notice the space plane, oddly enough, by Pan Am, which of course no longer exists as a corporation. But the Pan Am space plane, when it docks at the space station in 2001, they play the Blue Danube music during the docking manoeuvre. And yes, Commander Terraforming, quite right. The maximum speed of your ship in frameshift drive, you'll notice, is pegged at 2001 times the speed of light, which probably is a nod to Stanley Kubrick as well. So it's nice to see those little nods to sci-fi franchises throughout Elite Dangerous. So this Anaconda is sitting right in my camera viewport. Nice, whoever that was. Very, very skillful flying now. So yeah, it's a bit of an odd film actually. 2001. It's not necessarily what you might expect, and compared to a modern film, it's very slow paced. But it is quite realistic in the sense it does, spaceships in space don't make any noise and they don't appear to move, and there's no warp drive effects or anything like that. So it's got a nod to realism in many places. It's pretty well done for its era. And there you can sort of see the rings of Jupiter. Now they're not nearly that obvious in real life. Nowhere near that obvious. In fact, visually, if Jupiter is in the sky, you wouldn't be able to see them at all. They're that faint. They're really quite dark and really quite small and really quite thin. But they do exist. So we've got to acknowledge that. It appears that most gas giants do have rings of some sort. But the ones around Saturn are by far the most obvious ones, which of course is where we're going to go next. So the moons of Jupiter. You can see those with a telescope from the ground here on Earth very easily. If you have an ordinary telescope, point it up at Jupiter, you will see it. You will see the moons of Jupiter, and you'll see them change position from night to night. They go round fairly quickly, and from one night to the next, you'll see them. They'll have changed positions, and it's quite fun to see how they work. So that's quite cool. There is also, of course, on Jupiter the big red spot, which is known now because it's not very red anymore, and it's getting smaller. Back in the past, it was way bigger. It used to be about 4 times the diameter of the Earth, whereas nowadays it's barely more than 2. And the thinking is that maybe the red spot is just one of those transitory features on the surface of Jupiter, which we were lucky to see in the earlier parts of the 20th century. And now, as we get into the 21st century, it's just slowly fading away. So it's an interesting place. Massive, great big ball of hydrogen, methane mostly. There is no surface there. Not that we could get to. The pressures inside Jupiter are immense once you get down to things. It gets the pressure's so high at the core of Jupiter that hydrogen apparently begins to become a metal, so it acts as a metal under incredibly high pressures. And Arthur C. Clarke actually theorized that maybe there was a crystalline core at the center of Jupiter, which was about the size of the Earth. So if you can imagine a diamond the size of the Earth at the center of Jupiter, that's quite a nice image. But of course, it's forever beyond our reach. There's no way we can get down there to do anything with it. So anyway, interesting stuff. Right, so let's set course for the next one, which of course is Saturn, which is obviously the most beautiful planet in the solar system. Now, we don't have too many places where we can what happened there? Rendezvous. So we'll rendezvous at this space station here, Titan City, which is in orbit around a moon Titan. We'll go from there. Now, I do want to try and do a little bit of a flyby of the rings, because of course the rings of Saturn are dramatic. You can see them through a telescope as well. Even in a small aperture telescope, you will be able to see the rings of Saturn very clearly, and it's quite a sight. We tend to be a little bit spoiled nowadays, okay? Because of course, if you want to look up a nice picture of a planet, you just go onto Google, type Saturn, and then boom, there you go. You've got a fantastic thing. And games like Elite Dangerous and Space Engine and all of these astronomicals do spoil us a little bit, because we get these beautiful close-up images of things. And of course, you can't see anything like that through a home-based telescope without quite a lot of work, and you need to be fairly deeply into your astro imaging to get big, high-resolution images out of telescopes from the Earth. That's fun, but it's quite an undertaking. Through visually, if you want to see Saturn visually, and you just look through your telescope at it, you need quite a big magnification, quite a lot of patience, and at the end of the day, you're going to get this very tiny little image in your eyepiece of Saturn. But, compared to a Google Images, it's not going to be all that impressive. But there's something quite mystical, I think, quite intangible, quite quietly, strangely reassuring almost, about seeing Saturn through your own telescope, because you're seeing the real thing. Then you're not looking at an image of a projected image or a photograph or a CGI image or whatever it happens to be. You're looking at the real thing, and that does make quite a difference. And Saturn has a mystique all of its own. It is an interesting world, and seeing it through a telescope for yourself is just one of those wow. I've seen Saturn through a telescope. It's quite a thing. It's more so than any of the other planets because, of course, of the rings. The rings just make it an utterly different thing to look at. Jupiter's impressive, and you can see the bands and you can see the moons, but Saturn just doesn't look like anything else in the sky because of of its rings. They're quite dramatic. Right. So as we sweep majestically past, there we go, Jupiter. I don't think the big red spot is modelled in Elite Dangerous. I don't know. Maybe it is, but it's nice to see Jupiter go past. There we go. Move the mouse nice and slowly so I don't give everybody seasickness. And off to Titan we go. So Saturn is quite a lot further out than Jupiter. It takes about 23 years to go round the Sun, I think. So it's a long old time. And it is actually the furthest planet you can see with the naked eye from the Earth. So this is the furthest object in the solar system that you can see from the Earth without any optical aid at all. So strictly speaking, you can see Uranus or Uranus or however we're how to pronounce it. I'm going to use Uranus because that's what most astronomers do nowadays, because we've all grown up from being teenage boys who think Uranus is funny. So Uranus is how I'm going to pronounce it right now on. But Saturn is the last planet that was known in ancient times. Okay, Uranus is technically possible to see with the naked eye, but it's incredibly faint. It's right on the limits of vision, and if you're not looking for it, you're not going to spot it. You have to be really lucky. Commander Sea Dweller says, "Speak for yourself. I haven't grown up. I still think it's funny." Just for you, Commander Sea Dweller. Well, we'll get to Uranus in a bit, okay? So Saturn is the last one you can see with the naked eye. Effectively, Jupiter is incredibly bright. It's way brighter than any other star still. So that shows it. So Jupiter is easy to spot because it's brighter than the stars. Saturn isn't. Saturn looks very much just like a star. It's outshone by bright stars like Sirius, and yes. Oh, I'm doing the loop of shame. I'm not moderating my speed. Oops. There we go. We can see the rings. We're going to go straight past. Whoops. Sorry about that. Wasn't paying attention. So yeah, what was I saying? Concentrating on the flying. There we go. Right, we're coming a bit back behind Saturn, so we'll fly back over there in a minute. Yeah. So Saturn's the last planet you can see. And it is it's not particularly bright. It's outshone by some of the brighter stars. The way to check that you have spotted a planet in the sky is that you probably remember that little nursery rhyme, particularly in the UK, "Twinkle, twinkle, little star, how I wonder what you are." Is in the sky, because of the atmosphere, stars twinkle. And even the brightest ones, you'll notice, and particularly the brightest ones actually, you'll notice that particularly when they're lower down in the atmosphere, lower down towards the horizon, they will twinkle. And that's because they're effectively point sources of light at a great distance. And so the light from them gets wobbled around quite a lot by the atmosphere as we see them. Oh, there we go. Look, we've got Titan and Saturn both at the same time. And as a result of that, stars twinkle. Now, planets, because they're much closer to us and they're bigger, now we can't resolve them to our eyes as disks, but they are disks in the sky, which means that their light doesn't wobble as much from our perspective, which means that they don't twinkle. So if you look up and see something bright and it's twinkling, it's a star. If you look up and see something bright and it's not twinkling, the chances are you're looking at a planet. So that's the easiest way to spot the difference from the Earth. So here we are in close to Titan. Now Titan is the biggest moon of Saturn. It's a moon that is quite a lot bigger than our moon. Relative to Saturn, of course, it's tiny, but it's a big moon, one of the biggest in the solar system, and it's got an atmosphere. Okay, so here's a moon with an atmosphere, which is again quite an unusual thing for our solar system. Anyway, it's a moon with an atmosphere, and the atmosphere is pretty thick. Actually, it's actually thicker than Earth's. You're looking at a UFO. Yes, there is that point. The atmosphere on Titan is quite thick. Okay, it's thicker than the Earth's atmosphere, and it's sort of a hydrocarbon smog. It's not particularly nice. And it's incredibly cold out here, by the way. We got to a point in the solar system where everything is measured in Kelvin above absolute zero rather than in centigrade, because centigrade just has lots of minus numbers. So it's really cold out here. The sun's radiation is minimal really compared to Earth, and as a result of that, it's freezing cold. I mean, freezing isn't the right word to use out here. Okay, it's incredibly cold. Really chilly. Water out here is a rock. Okay, it's not even ice. It is ice, but it's so cold and so hard and so solid. It's effectively a rock. And liquid is other things. Okay, things that would be gases on the Earth. So methane, for example, on the Earth is a gas. On Titan, methane is a liquid. So methane is now taking the role of water on the Earth and acting as the lubricant and the thing that's eroding the landscape, whereas ice is actually rock on Titan, whereas of course on the Earth it's a liquid. So different chemicals take on different roles in different parts of the solar system, which is quite interesting if you're into that sort of geological sort of stuff. And we have things like cryovolcanism taking place out here, where things that we would expect to be gas on the Earth have become liquid, and they are therefore volcanically active as a liquid, like lava is on the Earth. But the temperature is so much lower here that things that we would think of as gases are actually the cryovolcanistic components, which is really weird. We see nitrogen volcanoes on some of the outer moons in Neptune's orbit, and here we see methane and things like that acting as a volcanic stuff. So Titan is an interesting place, and they think there are lakes of methane on the surface. And imagine that a lake on the surface, but not water, but made of methane, and other hydrocarbons and all sorts of weird stuff like that. So it's interesting place to be, and its atmosphere is really thick. And we actually landed a probe on Titan not so long ago, the Huygens probe, and it went down and landed successfully and took some images from the surface of Titan. So if you haven't seen that, look up the Huygens lander, and there's actually videos of it, what it saw as it descended into the atmosphere of Titan. And there's all sorts of weird stuff happening out here in the outer solar system, which are interesting. So Titan's one, a moon with an atmosphere and sort of hydrocarbon lakes. Kelvinator is mentioned Enceladus. Now Enceladus has got some outgassing that's so energetic, it's sort of leaving a trail of stuff around the orbit of Saturn, which is quite interesting. And there's another moon of Saturn called Apatus, or Japatus, depending on how you pronounce it. Which is really odd. I don't think it's mapped properly in Elite Dangerous in the sense that of real life. But let's just have a quick look, because I don't think it is. There it is. There. In real life, one side of Apatus is black, and one side of it is white. And the reason for that is it seems to be travelling through a dusty area in Saturn's orbit, and one side of it's getting covered in black stuff, and the other side, of course, is effectively clean because the planet is orbiting into that black stuff only on the one side. It's not represented like that in Elite Dangerous, unfortunately, but Elite Dangerous doesn't have photorealistic mappings of the world, which is a little bit of a shame because those mappings are publicly available, so Frontier should be able to pick them up and then stick them on to planets in the solar system to make them look a bit more realistic. But there may be reasons in the Stellar Forge why that can't be done. So yes, there's some weird stuff happening out here in the outer solar system, with weird volcanoes and stuff, and planets where they've got atmospheres and lakes of methane and all sorts of interesting stuff. It would be cool to be able to get down and have a look around, but of course you can't do that yet. So it's going to be interesting to see which, if any, planets are unlocked by Odyssey. Will some of these moons have a little bit more? Would we be able to go down on the surface of Titan, for example? Does that count as a tenuous atmosphere? Well, not really, so probably not. But Mars is a possibility, I suppose. Although Mars is terraformed, of course, in Elite Dangerous, so maybe not there either. So we'll have to wait and see whether they're going to allow any access to the planets in the solar system. more than we have now. That's going to be quite interesting fun. So I want to take a trip out over the rings of Saturn, because while we're here, why wouldn't we? Because it's the site in the solar system. So frame shift drives on, and we're just going to literally cruise out to the orbit of Saturn. See how we do. So we'll form up at the next destinations. The dull ones. Duplex. Oh, you're so cynical. The dull ones will get unlocked. Well, that's the problem, isn't it? All the interesting places we want to go to are, of course, are the more complicated ones to render, aren't they? Which is always tough. So anyway, let's fly past Titan. Now, to visual wavelengths, Titan doesn't have much in the feature. You can't see through the fog. This was a problem when Voyager went to look at Titan. We couldn't see much. As you can see, we can't see much here really because of that thick atmosphere. The probes that went there later, the Cassini probe and the Huygens probe, actually had different cameras on board. Oops, didn't mean to press that button. So they could see through the smog, so they used different wavelengths. Oh, there's a nice res site in the rings. I suppose we could do that. Okay, let's try that. It might be a bit risky. Let's drop into the rings themselves at a res site. I'll see if that will come up on my. Let's drop myself out of Super Cruise there. Yeah, so we managed to be able to see down into the surface of Titan, which was quite good. And there'll be pirates at the red site, so we'll have to be a bit careful. Let's see what we can see. Now I'm going to come above the plane of the ecliptic a little bit here, so we can actually see the rings. Because of course the rings are incredibly thin in real life. They are just tens of miles thick, tens of kilometers thick, but of course thousands and thousands of kilometers in diameter. And it's thought that they are the remains of a moon that disintegrated because it got too close to Saturn. They may be a relatively new thing. They may not be around for very long. So we're kind of lucky, maybe, as humanity, to be seeing them here today. So I'm looking for this res site. There it is. There. So it's the one I'm looking at looks like it's on the inside edge of the rings. So we'll try and head there. We'll just keep an eye out for any pirates, okay? Can rendezvous there. So we get a nice view, and I'm just going to cruise into Saturn's ring. Now, this view of Saturn is one that's been taken by many space probes, okay? So, the rings and the sort of amazing majesty of these multiple rings, it was clear early on that they couldn't be solid. But it took a while before we realised they were made of small chunks. But no spaceship has ever been able to get close enough to see the view of the rings that we can see in Elite Dangerous. We've never been able to resolve the individual chunks of ring material like we can in Elite Dangerous. Which I'd love to see that personally. I'd love to see what the rings actually look like at kind of point blank range. One of the things we have seen, which Elite Dangerous doesn't do, in fact I haven't seen it in any of the space sim games at all, is that along the edges of the rings are bent upwards into like little jagged mountains, and they are, and that's by the action of little moonlets that float around at the edge of the rings. That's really quite cool. And some of those mountainy sort of areas cast shadows on the rest of the rings that you can actually see. There are a few images of those sort of shepherd moons and the ripples they create in the rings, which are definitely worth seeing. So if you look them up on Google, they're quite interesting to see what's going on there. So as we get closer, the rings. I mean, we don't know, of course, exactly what the rings would look like at this range. Nobody's ever been able to go to. They didn't even think of sending a space probe through one of the gaps in the rings, but they realised fairly quickly that the gaps weren't exactly gaps. They still had stuff in them, and it would have been really, really dangerous thing to do to send a space probe through there. The chances of it surviving would have been quite low. So anyway, we're going to just drop into. Here we go. Boom. and then we drop into the rings. Now, this, I mean, this is what we think it looks like. We really don't know, actually. There are a few ships fighting around there. So the system authorities are arriving in 0 minutes and 0 seconds. Excellent. That's good. So we'll just sort of fly around. Now, this is what we think the rings look like. It's a reasonable assumption. We've really no idea whether this is accurate or not, but it's quite good. It would have been quite cool to see if a spaceship had gone through the rings, but you know, if it's anything like this density, of course, the chances of it making it through would have been risky, to say the least. But the fact that the rings are very thin and composed of rocky debris, they're probably composed of a lot more gravel than we're seeing here. So Elite Dangerous obviously renders the rings as quite large chunks, and that's down to graphics. In reality, the rings are probably much more composed of much smaller stuff than we're seeing here. There will be some big stuff floating about, but most of it will be gravel. So actually, it would be quite a dangerous thing to fly through, because you know, at any kind of space speeds, you know, hitting gravel is not a good thing to do in a spaceship. So rather than it being, you know, big discrete lumps of rock serenely rotating like this, it would be more like flying through sand at very, very high speed, and you know, bits of gravel. You know, but there would be big chunks about. But it would be highly dangerous. So it probably doesn't look exactly like this. It probably looks more like lots of floating sand and gravel in sort of streamers and things like that. I'd love to see it up close. It would be fantastic to see, but alas, probably not something that I'm going to see in my lifetime, I suspect. But it would be cool. And the possibility of successful navigating asteroid field is approximately... Well, this is one of the things that, you know, asteroid fields in space science fiction movies are always wrong. Okay, so this, of course, isn't an asteroid field. This is a set of rings, but you know, a real asteroid field is not dense like this at all. Asteroid fields are separated by millions and millions of miles, so asteroid fields don't look like asteroid fields at all, unless you kind of congregate near Lagrange points and things like that. But maybe that's what they were doing in Star Wars. Who knows? But yeah, this effect is much more, you know, a planet's rings. Maybe that's what they were flying through in Star Wars as well. Who knows? But we can't criticise that too much. So, but fun things to fly through anyway. So, does Saturn's rings really look like this? Well, probably not quite like this, but you know, this isn't a bad representation. And you can see actually Elite Dangerous does do, as you can see, a few small chunks of stuff flying about, which is perhaps a little bit more realistic. And it goes on for, you know, miles and miles and miles into the distance, which is entirely correct. So. And we all know that sand is coarse and it's rough. It gets everywhere, yeah. So there we go. Anyway, Saturn is a majestic planet. It is, like I say, the last planet you can see with the naked eye from Earth, and it is pretty big. It's not as big as Jupiter, but it's certainly the second biggest planet in the solar system. Lovely place. Right, let's go onwards, because we got things to see, places to go. Now we're going to head for aerial. There aren't any systems out here to, you know, space stations to rendezvous at, so we'll have to do our best and see what we can find. So let's head for Uranus. Commander Sea Dweller will head for Uranus, and we'll go from there and leave Saturn behind in the glory of his rings. Oh, we've got to fly through the rings. Let's do what space probes can't do then, because I've got an exploration ship. Not quite sure what Carl Sagan would think of me recklessly throwing through the rings of Saturn. Yeah, that's a good point, actually. Yes, Commander Terra. That's one of the classic... not Commander Terra. No, that's Tuplex. One of the classic quotes is that Saturn is so light, i.e. density, that it would float in water. And that is true for, you know, for the average density of Saturn. Of course, Saturn is absolutely massive, so you need quite a large container to put it in. And that would give you all sorts of other trouble. But in essence, yes, you know, Saturn's density is so low that it would float in water, which is a bit weird. No, mustn't make fun of Uranus's name. No, that's you know, totally inappropriate. We won't be doing that. Right, let's get our ship into frame shift. Interestingly enough, Uranus seems to be almost directly in the direction of Orion, which is quite nice. And we can now see up there, we can see the Hyades, which we'll go to later on. And up there, just behind the rings, is the Pleiades. So, which of course, in the time of Elite Dangerous, is the home of the Thargoids, which we've discovered in the Lore Tour as well. So we're heading to Uranus. Never gets old, does it? Never gets old. Never mind Dyson fears, we need a Sagan bucket. Yes, that's exactly what we do. So Commander Kelvinator is off to Uranus as well. We're all plotting courses to Uranus, which is very naughty. Stop it. That's all good stuff. Right, let me just flip onto the rear view camera. Because we're leaving Saturn, which probably looks quite nice. There we go, look at that. See, the eye candy in this game is still really, really good, isn't it? It does look quite majestic the way that we disappear. There's a few of you commanders out there in frame shift as well. Does look impressive. If only we had spacecraft that could really do this, right? Yeah. Fly away at multiple times the speed of light. I mean, I'd be happy even if we didn't have a hyperdrive. Okay, I'll give you that. Yeah, hyperdrive's probably hard, but come on, give us the frame shift drive at least, right? You know, go touring around space. It would be good. Alas, unlikely to happen. So right, off we go to Ariel. Now Uranus is not a particularly interesting planet visually. Okay. It's a sort of green colour. It is just about visible to the naked eye, but to be honest, I've never managed it. I have seen it in a telescope, but I've never managed to see it to the naked eye. You have to have such a dark sky and such ideal lighting conditions, seeing conditions that it would be a real challenge. And I think I'm probably past the age where my eyesight would be up to the job. Maybe if you're young and the conditions are perfect, you might be able to see Uranus, but it would just be a really, really faint dot in the sky, so not really worth it. Easily seen through a telescope, but wasn't known to ancient astronomers. It was the first planet to be discovered in kind of modern times by William Herschel. And he wanted to name it George, after King George, of course, because Britain, etc. It was one of those things that you did back then. You named a planet after your king. So, but it didn't stick. So we had named our planets after Roman and Greek kind of mythology, and so it continued on. Uranus is a slightly odd planet in the sense that it's very, very tilted over on its axis. So whereas the Earth axis is mostly upright, okay, we're about 23 degrees tilted. Uranus isn't. Uranus is rolling around on its side. Its axis is about 80-something degrees. So sometimes its north pole is pointing at the sun, and sometimes its south pole is pointing at the sun, and sometimes it's side on, depending on which part of its orbit it's in. So something happened to Uranus to set its axial tilt way off compared to all the other planets in the solar system. It's a bit strange. As you can see as we approach, it does have some very faint rings, which were discovered when they occulted starlight a few years ago. They're very, very faint again, but they're reasonably accurately represented here. They're very thin. So Uranus may have been hit by something. It would need to be something pretty big to knock it over. But as you can see, it's a sort of greeny blue sphere. There's very little in the way of markings on it. There's just not much to see. But it does have 5 decent-sized moons, as we saw on the approach, which Ariel is the closest one. So we'll see how we can get out there and have a look. So there it is, going past the starboard side of my ship. But again, a featureless planet. Now, it's these Uranus and Neptune are known as. Oh, is it not tilted in ED? That's interesting. We should have a quick look at that, because it should be. Because you can see if you map it, If I switch mode, then does that show me the? Yeah, there we go. We'll have a look at that in a moment when we come out of. Although we can only see it in frame shift actually. I'm just going to turn around for a moment. Let's have a quick look at that. Is it not tilted correctly? Another thing we should add to the snagging list of dangerous accuracy. So where's the sun? That's Pluto over there. Where's the sun itself? Don't even know where the sun is. Hang on, I should be able to work it out by switching mode. Right, that actually, so the sun is. Oh, the sun's over there. So that's the sun actually. That bright thing there is actually somebody in frame shift. So the sun's actually there. So yeah. So looking at that. That's wrong. Yeah, Uranus should be much more tilted than that. So somebody hasn't quite done their homework on the axial tilt of Uranus there, in terms of what it should be in real life. So in reality, the tilt is much more extreme. That appears to be virtually straight up, which is not correct. So yeah, so we should have words. We should have words with Frontier on astronomical inaccuracies in game. So anyway, here's aerial. There's quite a lot of us approaching here. Whether we can drop out anywhere. Maybe I'm tilted wrongly, says Burnell. No, well, it's the tilt for and away from the sun that we should be looking at. So even if I'm tilted wrongly there, it can't be wrong compared to the orbit lines of the solar system. Well, I suppose we could check that actually. That's a good point. Let me switch orbit lines on. Let's just see if it. Oh, that's the wrong button. That's a very good point, because I'm assuming that I'm in the correct orientation, which I might not be. Orbit lines, where are they? Orbit lines. There we go. Right, let's go back and have a look. That is a very good point. I might be misrepresenting. Right, so that's the orbit of. So, hang on, which orbit lines are we looking at here? So it could be. Ooh, well, is this the orbit line of what? Is that the orbit line of? I need to. I'm going to fly out a little bit because I can't see which orbit line that is. So excuse me a while I take a short detour. Maybe I've dissed FDev unfairly. Maybe they've done this correctly. I'd be surprised if they haven't got it right actually. Right. So what are we looking at there? That's Umbriel. That's one of the moons. So let me just turn around. So there is, right, we're sort of hovering over the North Pole and of Ariel. Okay, it's not Ariel we need to know about. So that's the orbit line of Ariel. I'm just curious now. Okay, so that must mean that Uranus itself is in the middle of this orbit line. There's lots of people flying around. Right, so there, hang on a minute, what am I doing? So that is therefore, okay, those are the orbit, those other orbit lines up there are the orbit lines of the other planets. So no, that isn't correct. So that's not correct. So there are some things that are off on weird wacky lines there, but the orbit lines of the rest of the solar system, as you can see there, are at the same plane as Uranus. So Uranus is pointing upright. It's tilted in the orrery, is it? So yes. Let me just zoom out a little bit further. Let's do a 90-degree climb. Just zoom out a little bit. I just want to check that. So let's just zoom out a bit further so we can see. I'm pretty sure that's the sole orbit line that we're seeing there. That's probably enough. So again, tilt down. Alright, so yeah, so there is, now we can see, those are the ring. Actually, those are the rings, aren't they? So I can't see the sole orbit lines actually. And where is Sol? So let me just target on Sol. Sol is there's Sol, but it's not giving me the orbit lines for Sol, which is a bit of a nuisance. Oh, hang on, no, there we go. So actually, no, look, I think I've done them a disservice. No, look, it looks like Uranus is correctly tilted. So maybe they've done a good job. So I think that's the Sol orbit line, isn't it? Yeah. So if that is the Sol orbit line, then Uranus is wackily tilted. Hey, good for them. Good for them. I will let them off. I think that's the Sol orbit line I'm seeing there at that. Oh, it's lost it again. Seems to be a bit random as to when it appears or not. There we go. I think that's it there. So if that is, then we've got a good tilt to Uranus, which is correct. So good. Anyway, props to Frontier if that's the case. So well done. I must admit, I don't like the orbit lines on, because I find they're kind of like too much. But anyway, so there we go. So yeah, we still have words about Phobos, Deimos, and Ceres, but we'll give them Uranus. But for Commander Sea Dweller, Frontier have done Uranus correctly. Right, we must move on because time's ticking. Actually, we've got to get to. We're going to do the classical planets. So let's get to Neptune. Interesting, Triton is permit locked. Why is that? We wonder. So yes, astronomical accuracy. We give points to Frontier for that one. Really, really good. So let's get ourselves out to Neptune. Oh, I pressed the wrong button again. Zip. I didn't want to do that. No, I'm stuck. Right, let's get ourselves out to Neptune. Now, Neptune actually is on the entirely different side of the Sun at this time of 3306. So it's a little bit of a trek. But of course, with the frameshift drive, the magical frameshift drive, we don't need to worry about that. Oddly enough, the only reason we managed to visit Uranus and Neptune, and we've only visited those planets with a single space probe in the entire history of the humanity so far. And the reason for that is they're just so incredibly far away. Okay. Now I've got blue tunneling. Oh, off we go. They are so incredibly far away, and it was only the only reason we were able to visit them at all was that because there was a fortuitous alignment of the planets back in the 70s, which won't repeat for quite some time. I don't quite how often it happens. It's not that unusual, but it's rare enough that it doesn't happen very often. And it was happening in the 70s. And the astronomers knew this, and they basically said, look, NASA, if we send a spaceship to Jupiter, we can use a technique called gravitational slingshotting to get it to accelerate onto Saturn. But because of the way the planets are lined up, we can also gravitationally slingshot from Saturn to Uranus, and then from Uranus to Neptune. We can do all four for the cost of one mission, as long as we design a spaceship that can, last that long. So they built Voyager 1 and Voyager 2 able to do that. Voyager 1 didn't go to Uranus and Neptune. It was sent on a trip to Titan, which turned out to be a bit of a waste of the spaceship, unfortunately, because they wanted to have a look at Titan because they knew it was a bit strange, a bit different. But the Voyager 1 cameras couldn't see into the atmosphere of Titan, so they didn't get much from that decision. So Voyager 2 wasn't sent to Titan, it was sent on to Uranus and Neptune, which it did eventually reach after many, many years of travel, and has taken the only close-up pictures of Neptune and Uranus that we've actually ever got. No other spaceships have been there. So the only images we have of Uranus and Neptune today are from the Voyager 2 spaceship back in the 70s. That's all we have. We have nothing better. The Hubble Space Telescope has managed to take some quite good images because, of course, it's pretty impressive. But it's obviously in Earth orbit, so it's not quite as good as that, being on site with a spaceship. But and we've sent obviously one spaceship out to Pluto, which was the New Horizons probe. And you can actually go and visit that in game. In fact, you can go and visit Voyager. I don't know if you can visit Voyager 1 and Voyager 2 in Elite Dangerous. You can certainly visit one of the Voyagers. I can't remember which one it is. Or maybe both of them are out there. I can't remember now. And I know you can visit the New Horizons probe as well. So if you're tooling around the solar system, wondering what to do, you can go and visit the probes that we sent out in the 20th century. They're still in the Elite Dangerous now. Okay, they're both there. Oh, brilliant. Okay, fantastic. Thanks, Bold Pigeon and Kamichi 9 and Sapphire. And the Bearded Bard even. But it takes quite a long time to get there, even at frame shift drives, okay, because they're quite a long way out. And by 3306, they're quite a lot further out again. So Voyager 2 took pictures of Uranus and Neptune. Voyager 1 was ejected from the solar system because of its rendezvous with Titan, heading out kind of upwards, I suppose, if that makes sense. It's a long way out. It takes quite a long time to get there. Flying around the solar system is straightforward and Elite Dangerous, but the Voyager probes are a long way away. But they're quite good fun. If you go to the Voyager probes, you can hear, I believe, they're recording. You know, they on the side of the Voyager probes there is a disc, a metal disc, which contains the sounds of Earth. And Carl Sagan was one of the people who helped put that record together. And you can hear some excerpts from that disc in Elite Dangerous if you go close to the Voyager probes, which is quite neat. So if you like that sort of geeky nod to things gone, then you can go out there. But it takes quite a while to get there. Be warned, it's quite a long way out, even at supercruise velocities. And of course, so what they've done in Elite Dangerous is rather cleverly. They've worked out approximately where those space probes will be in the year 3300, which means they've been travelling through space at 25,000 miles an hour, whatever it is that they've been travelling, for over 1,400 years. They are quite a long way out in space by that point in time, but it's worth a trip out there, just for the thing of going to go and see Voyager 1. So if you're in Seoul and you haven't gone to see them, maybe now is your chance to go and have a look. So it's definitely worth having a look. Neptune again is very similar to Uranus. It's a bit colder, it's a bit further out. Both of these planets actually radiate more heat out from themselves than they get from the sun. And as Sapphire says, actually Voyager 1 and Voyager 2, you can scan for them with the FSS, but you can triangulate their position with the stars. You will find them. They are in the correct space in the sky. So that is, again, a lovely piece of a nod to things from Frontier again. Neptune here is a more bluey planet than Uranus. Again, you can see some very faint rings. The illumination out here is pretty faint. We're a long way from the sun out here. It's extremely cold. There is a bit more coloration to Neptune than Uranus, but not a great deal to see, to be frank. There's a little POI out here, Conjoint Mathematical Services. Don't know who they are. It's interesting. Haven't spotted that before. And Triton is a strange moon. It has a permit. And I don't know why that is. It's there. So that's the thing. Now somebody's saying here about the installation. So what's the installation? I don't know what the installation is. Is that something that? No, the mathematical one. Okay, so let's go there then. I've lost it now. There we are. Let's go to that. A faction-owned installation. There we go. So let's go there. So so Triton. Don't know why it's permit locked. I don't recall anything in the. So Conjoint Mathematical Services is where we're heading for a quick rendezvous. Then we'll proceed to Pluto, and then we've got to organise ourselves for one last little bit before we venture off into the evening, because it's already gone 10 o'clock. It takes a long time to get round the solar system. In 2 hours. There's quite a lot to cram in. So let's meet up here. Even with a frame shift drive, it's taken a good 2 hours to tour the solar system, which is good. It's good fun. I think I got a little bit too close to the gravity field there, didn't I? Yeah, we don't know a great deal out here because Triton is the Womble homeworld, okay? And the mathematicians need to isolate themselves on the butt of the solar system to concentrate. Well, that's probably true. It is probably nice and quiet out here, isn't it? So maybe there's obviously a bit of lore that someone's written about Neptune, but why would Triton be permit locked? This is a very good question. Same reason perhaps we can't land on the moon at the moment, but it's kind of reserved for future content, so we'll have to wait and see. So here's a good rendezvous point here. We can bring ourselves together. Ooh, blue tunnel again. Bum, 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 bum. Yeah, the Wombles are still looking after themselves. Oh, Triton's where the clangers live. Fair enough. I could swear as a kid I could understand what they're saying. I think your ability to interpret the clangers disappears at about the age of 8. There we go. So this is a big installation here, isn't it? Use the data link scanner to search for targets. Well, so I'm not quite sure what they're doing here. It's a scientific installation of some sort. So let's wander past that. Thanks for the hello. Always good. A Braben tunnel and a soup dragon. So what is this? Could it be lights, or is that? Be careful flying through there. Just turn my headlights on. Night vision. Oh yeah, it is a space. Okay. So yeah, so that's quite a nice thing. I think why it's out here. Maybe there's some things to scan, but looks a little bit like a reused CQC asset to me. But yeah, nice to see those sort of things being in the game. So there we are. That's an installation there. Right, let's hot foot our way to Pluto because that's the last place on our destination. Now Pluto is kind of a double planet really. So we've got Pluto and Charon. So we'll go to Pluto first, and we should be able to see Charon from there. So set course for Pluto. Too close to the installation. And we'll head out over to there. Which again looks like it's on the opposite side of the solar system. Now again, we've only sent one space probe to Pluto, and that was the New Horizons probe. That arrived, after like a 10-year voyage it took to get there. But Pluto turned out to be way more interesting than we thought it was going to be. Well, at least I thought it was going to be, because you kind of expect a planet, or actually, and it's not. It got demoted a few years ago, which for many of us in the astronomical community was a bit of a kind of a sore point, because Pluto was always the 9th planet, and suddenly it wasn't. We only had 8 planets in the solar system. We lost Pluto because the International Astronomical Union, these austere kind of top astronomical folks, decided in their great wisdom that Pluto was no longer a planet; it was a dwarf planet, and as a result, Pluto was demoted in the galactic scheme of things, and no longer was a planet, which I always thought was a rather curious definition. So their definition of a planet was something that was orbited the sun, which differentiates it from a moon, which I think is perfectly sensible. Something that is spherical, i.e. it's big enough to have coalesced into a spherical shape, so it's not an irregular shaped object like say an asteroid, a small asteroid. That sort of makes sense. But they also said it has to have cleared its orbit, which doesn't really make a lot of sense to me, because there are quite a few asteroids that share the orbits of Earth. There are Lagrange points and things like that which contain debris from the Earth and Mars and Jupiter and Saturn and all the other planets. So none of those big planets can really have claimed to have cleared their orbits. And strictly speaking, most planets aren't spherical anyway. They're slightly squashed. So it's a bit of a dubious interpretation. I kind of get the first two. I think they're reasonable. But I think the reason they don't want planets like Pluto to be actual planets is because there are too many of them out in space. There are loads of them. You can see them on the Elite Dangerous System chart. They are, there's loads of them. For some reason, I think David Braben went a bit mad here and added loads and loads of things in, which is fine, but because they aren't really there. And Eris was, found to be slightly bigger than Pluto, which of course, if Pluto's a planet, then Eris would have to be as well. But Eris was sort of, much further out and much more elliptical. I mean, Pluto's orbit is strange. It's not mostly circular, though all planets are elliptical orbits, but Pluto's was very much elongated to the rest of the solar system. So I get that sort of stuff. But now we've got this slightly dubious definition of dwarf planets, which are planets that don't fit into those three categories. They match even one or two of them, and it's just another class of objects. And then you get into all sorts of kind of which ones straddle the boundaries. And it's like anything. The moment you put a categorization in place, you will quickly discover things that sit, blur that category and make that category hard to enforce. So. Our local astronomical society, Ashford Astronomical Society, which is the one I go to on occasion, came up with a much better definition of these things. We call them space rock thingies, and that seems to encompass all things. And we have a fairly wide-reaching set of categorization and criteria for space rock thingies, which is fairly inclusive and doesn't cause any arguments. But anyway. Pluto, we visited with New Horizons probe, and it was discovered to be far more interesting than we expected. Now, unfortunately, again, in Elite Dangerous, the surface of Pluto isn't represented with the photo imagery that you can actually get from NASA. But if it was, we could see areas on Venus. Now, the weird thing is that there are areas on Venus where the surface is, again, geologically incredibly young. It's been resurfaced by some weird processes where ice and stuff has upwelled from the inside of the planet because of some process that we don't really understand too well. It flowed over the surface and just filled in all the craters and destroyed things. There are older areas and mountainous areas and flat, icy areas and all sorts of weird stuff going on the surface of Pluto, which, to be honest, came as quite a surprise when we saw it, because you'd expect something this far out to be virtually geologically inert, and yet Pluto turned out to be not geologically inert at all. And it's a bit disappointing in Elite Dangerous. It doesn't look right, because we've now got really cool imagery from the New Horizons probe. It doesn't look anything like that. So it's a little bit of a shame that Pluto doesn't have, and they could take that imagery and stick it on, I would have thought anyway, sticking that on the assets in the solar system, but unfortunately they haven't done that, which is a little bit of a shame. And over there you can see, just between the glare, you can actually see Charon, which is the moon of Pluto, and it's incredibly large. Again, as a moon, it's a big fraction of the size of Pluto. To effectively almost a double dwarf planet, really, and are quite weird. So, and that takes us out to the edge of the traditional solar system, the solar system that I grew up with. Now, we could keep going for a long, long way, but there's just more rocks out there. So, and Charon, I think was the god of the underworld or something. Was it Pluto? Pluto, the god of the underworld? I can't remember which one. Anyway, they're sort of underworldy, guardian-y type, all sorts of places that are distant. So that's the edge of the solar system. We have reached the edge. Now I want to take you back. Now somebody mentioned it earlier on. Kind of almost gave the game away, but we're not doing that. So let's go back so I can sign off in true classic style. Now we're going to have to do this. I want you to rendezvous at Mars High. Okay, Mars High Space Station. So everybody head there, and we'll fly out to some Marsy tunes. So that's where we're heading. So engage the frameshift driver, head for Mars High. And we shall leave the edge of the solar system and retreat back to the lovely warmth of the inner solar system, where things are still nice and things. You can see actually how far Pluto is out. There's the sun, and you can just see Jupiter just off to the left there. There's Uranus and a geological signal, which I assume must be on one of the moons. Pluto is such a long way out of the solar system. The sun itself just looks like another bright star. It would be noticeably brighter than anything else around the time, but there we go. So let's head back into the inner solar system and make sure that we are warmed up after a long sojourn in the darkness. Right, let me get this up. Nope, that's the wrong button. Recent projects. There we go. Charon should be a mass yes. Well, in fact, the moons of Mars are featured in Doom, didn't they? I think pretty. Am I right in thinking Doom was set on Phobos or Deimos? Yeah, apologies. It's difficult to tell how long these tours are going to run for, so I've kind of overrun a little bit. I do need to drop off in a minute. So our immediate hyperspace jump is not going to be quite so dramatic as normal. We'll do our best, okay? So assemble at Mars High quickly. We'll see what we can do. We'll allow a little bit more time in future episodes for a more coordinated hyperspace jump, but it's tradition, so we've got to do it. But we're headed back to Mars, and there's a reason for Mars, okay? Yep. So Mars High, because it's the posh place, the posh part of the Earth. So let's head back there. It can take us a little while to get there, actually. It's so far out. Commander Camden LG would like a wing invite. Let's see what I can do. Will it work? There we are. I'll try that. Cradle of humanity. There we are. So Mars High is 7,000 light seconds away. We're crunching in. Yeah, we're a bit limited. Yeah, I've kind of overrun on time a little bit, so not too much time to wing it. There'll be plenty of opportunities on the tour, I'm sure, to do other wing-in events. So, but we've got to do one because it's tradition. So we'll do our best. There we go. Commander Camden LG is in the wing, so we'll see how many people we can get in. But I do need to shoot. Look, it's 10:15. It's time for bed. Anyway, I hope you've enjoyed the tour so far. I mean, this is the sort of thing that I do. We waffle on a little bit about space and astronomy and stuff, and the occasional fact may creep in, as you've seen, and if there's some lore associated with these things, then we'll drop into those as well. And there's plenty more to see out in space, but we're kind of dealing with things that are visible from the Earth in the night sky, and stuff that I always, as a kid, I suppose, thought maybe one day I'll be able to go out to space and visit these things. Now, in reality, of course, the space program didn't get quite so advanced as I was led to believe by 70s and 80s sci-fi that it would. But games like Elite Dangerous and Space Engine allow me to go and visit these things, and in as close to a reasonable simulation as is possible to do nowadays. Certainly way better than I kind of could have anticipated back in those 80s days with the primitive computers back then. Where are we heading next? Well, next week we will start at Alpha Centauri, and we'll start touring around the local stars, the closest ones to Earth, and sort of start working our way out from there. So so stay tuned. But Alpha Centauri next week. Alpha Centauri. Right, here we come into Mars High. So we'll form up and then travel a little bit away from the away from Mars, and then set a hyperspace there. Well, I suppose we could hyperspace to Alpha Centauri. Actually, that's not a bad idea, is it? If you're bringing a fleet carrier, Alpha Centauri would be probably handy for next week. That would be really good. Because I don't think you're allowed to bring fleet carriers into Sol, are you? I think there's kind of off limits to fleet carriers. Will we go to Hutton Orbital? Well, maybe we could rendezvous at Hutton Orbital, because it's a long way to travel in game, isn't it? It takes ages. But we should get the Hutton truckers to visit. Actually, that's a good suggestion. That's a good call. So maybe we should meet at Hutton Orbital. We'll have to fly there or something, and meet the Hutton truckers. I'll give it some thought, because I know it's quite a long way out. There to Hutton Orbital. It's a trip that every commander must do once. I've done it a couple of times. It does take a long time to get there. Hutton Orbital, a bit of a thing. Right, let's get into orbit around Mars High. We'll set the hyperspace destination to Alpha Centauri, and we'll go. Right, let's get ourselves into Mars High. It's amazing that we're taking a trip from Pluto to Mars in just a matter of minutes, and it's still not fast enough. Yes, legend has it you can get a free Anaconda in hot and orbital. Wasn't for sale when I went there, alas, but yep, never know. Maybe we'll get lucky. You can buy a mug though, which of course is a rare good. So mug, the mug, for the mug and all that stuff is a story which goes back way to the beginning of Elite Dangerous, which I was actually involved in accidentally in some ways. Right, here's Mars High. So if you are lucky enough to be in my instance, then jump in here. We will select Alpha Centauri, which is there, as our jump destination. There we go, which is behind us. Sorry, Drew, I need to go already. Making space for your wing, though. That's no problem at all. No problem at all. Right, so there's Alpha Centauri. Actually, Mars is nicely visible there. Okay, so form up alongside me if you're in the wing, and we will jump out. So I need to go. Let's get the external display on. Yeah, exactly. There we go. Right, so of course we are in Mars. So there's only one. And before MIDI shenanigans. So yes, there's only one tune that we can play out here. Let me just zoom out. There we go. So for those of you who are near me, you can get in shot. There's a few of them out. There we go. And yeah, as we form up, then we can have a little bit. So there we go. I'm going to zoom right back further out. So right, are we ready? There's only one tune, so let's hope this one works. And here we are. So form up. There's plenty of music. I had fun doing this one. This is a really cool tune. Let's just roll the camera to the right a little bit. There we are. So, what time are we at? So let me have a look at the internal clock for a moment. Let's get into formation. I think we'll hyperspace 21:23 game time. Okay, that allows us to synchronize it. 21:23. So charge your hyperdrives, but don't go to full throttle. Go to full throttle on 21:23. So I'm just going to charge my hyperspace drive. There we are. But don't go to full throttle until 21:23. Shot again. So close up on me if you can. I'll just zoom the camera up. And we've got about a minute and a half before we hyperspace. Of course, the chances of anything coming from Mars, 1,000,000 to 1. But we come. Here we are. There's maybe 1,000,000 of us. Very cinematic. So we're getting close to the launch time. So we'll get a bit more organised for the future. I'll turn up the music now. There we go. There we go. There we go. People are launching. such a cool effect. I suppose I want to hit the hyperspace drive myself. Here we go. Well, off we go to Alpha Centauri. So that's our next stop. So next week we shall continue on to Alpha Centauri, which is the nearest star to the Earth. Well, kind of. Obviously, the Sun itself is the nearest star to the Earth. And Alpha Centauri itself is not the nearest star. So yeah, I'll have a chat with the Hutton guys, see if they want to do anything next week. So it might be Hutton, or it might just be Alpha Centauri. We'll see how it goes. But whatever way, we'll be back next Thursday, same time, same back channel, 8 p.m. UK time, for more of the Elite Dangerous Astro Tour. So thank you very much, my friends, for joining me. Hope you've enjoyed that, Elite Commanders, and we will be back for more Astro Tour next week. Until then, right on, and 07. So it's been a pleasure, as always, to have your company tonight. Really do appreciate it. Thank you very much, and be good, take it easy, keep working Galnet, see if you can solve those mysteries, and see how you go. I will see you next week. All the best, my friends. Be good. See you soon.